Welcome to homework.
Okay, we've got 4 different alcohols. We've got a cyclohexane with an OH. We've got cyclohexane with an OH and a methyl group. We've got cyclohexane with an OH across the ring from a methyl group. And then we've got cyclohexane in which the carbon which bears the OH has a methyl group. A neighboring carbon has a methyl group. Another neighboring carbon has a methyl group. Oh, and there's actually not a methyl group down here. That was a mistake. And the question is, which of these will have the highest pKa? What does highest pKa mean? Low pKa means more acidic. High pKa means less acidic. So we're saying what is the least acidic molecule here? And we know that one of the best ways to judge acidity is the stability of the conjugate base, right? The more stable the conjugate base, the more acidic the compound. Therefore, if we're looking for the least acidic, then we want the least stable conjugate base. Now, in each case, we have a hydroxyl, and the hydrogen that we're interested in is definitely going to be coming from the hydroxyl, right? That's the source of the acidity, is the OH. Now, recall that when you have an OH, that the acid-base reaction is that your base will come in, and that you will lose your hydrogen on your oxygen, but retain a lone pair. And you started with 2 lone pairs, so you're going to get 3 lone pairs total and a negative charge. Right? And then your base will become protonated, and in this case be positively charged because it was originally neutral. The point, though, is this is your conjugate base. And this is known as, when we have alkyl groups out for the rest of the molecule, as an alkoxide. So we're talking about what is the stability of the resultant alkoxide following deprotonation. Well, I don't know if you were aware of this or not, but alkyl groups are electron donors. That means the more alkyl groups we have around our hydroxyl, the more electron density is getting donated into the hydroxyl. And the more electron density that we donate in, the less stable the conjugate base becomes. Right? The conjugate base is negatively charged, and so the addition of electron density destabilizes the oxygen or the alkoxide. So then the question is, which of these alkoxides has the most electron density being donated by alkyl groups? Well, right away we can see this alkoxide has no alkyl groups anywhere around it, right? Likewise, this one has an alkyl group across the ring, but that's far away. This one has an alkyl group on the same carbon, but so does this one. And there are 2 additional alkyl groups on neighboring carbons. So we can kind of see that of the options, there is most and more alkyl groups on this alkoxide 4, than any of the other options. And so alcohol 4 has the greatest number of electron donors, which makes it the least stable conjugate base, which means it's the least acidic, which means it has the highest pKa. The answer then is 4.